This lighting system typically consists of momentary rocker switches, relays, and transformers. These switches have a momentary action, meaning that they must be held down to activate the circuit. When released, the circuit is broken. Relays are electromagnetic switches that control the power to the fixtures. They are typically installed at the fixtures themselves. Transformers reduce the voltage from the main electrical supply to the low voltage required by the fixtures. They may also be located at the fixtures. When a momentary rocker switch is pressed, it sends a signal to the relay. The relay closes its contacts, providing power to the transformer. The transformer steps down the voltage and sends it to the fixture. The fixture lights up. When the momentary rocker switch is released, the circuit is broken and the relay opens its contacts, cutting off power to the fixture. There are several advantages to this type of lighting system. Firstly, energy efficiency. The momentary action of the switches prevents the fixtures from staying on unnecessarily, reducing energy consumption. Secondly, precise control. Because the switches are momentary, users can control the duration of lighting with great precision. Thirdly, low voltage. The transformers reduce the voltage to a safer level, making the system safer for handling and maintenance. Fourthly, flexibility. The system allows for multiple fixtures to be controlled from a single switch, providing flexibility in lighting design. This lighting system is commonly used in applications where precise control and energy efficiency are important, such as retail displays, staged lighting, architectural lighting, accent lighting, and home automation systems. If there is no light, check if the momentary rocker switch is working properly and if the relay is receiving power. For intermittent lighting, check for loose connections or faulty relays. A buzzing or humming sound may indicate a faulty transformer or loose wiring. Flickering light could be due to voltage fluctuations or faulty contacts in the relay. When dealing with electrical systems, always prioritize safety. If you're not comfortable working with electricity, it's best to call a qualified electrician. Before working on any electrical circuit, ensure the power is turned off at the breaker. Use appropriate safety equipment, such as insulated gloves and safety glasses. Double-check all connections to ensure they are secure and properly insulated. Understanding the components is crucial. The momentary rocker switch acts as the user interface, signaling the relay to activate the circuit. Relays are electromechanical switches that can handle higher voltages and currents than the rocker switch itself. They isolate the control circuit from the power circuit. Transformers are used to step down the voltage to a level suitable for the lighting fixtures, often 12 volts or 24 volts, enhancing safety and efficiency. The principle of operation is straightforward. When the rocker switch is pressed and held, it completes a low voltage control circuit. This energizes the relay coil, causing the relay contacts to close. The closed relay contacts then allow higher voltage alternating current power to flow to the transformer. The transformer steps down the voltage to the required level for the lighting fixture. When the rocker switch is released, the control circuit is broken, the relay coil de-energizes, and the relay contacts open, cutting off power to the transformer and the fixture. The energy efficiency of this system is a significant advantage. The momentary nature of the switch ensures that lights are only on when needed, preventing wasted energy from lights left on accidentally. This is particularly beneficial in applications where lighting is used intermittently or for short periods. The precise control offered by this system is another key benefit. Users can easily control the exact duration of lighting, which is ideal for applications such as stage lighting or retail displays where specific lighting effects are desired. The use of low voltage is a major safety feature. By stepping down the voltage with transformers, the risk of electric shock is reduced, making the system safer for installation, maintenance, and use, especially in environments where people may come into contact with the fixtures. The flexibility of this system is also noteworthy. Multiple fixtures can be controlled from a single switch, simplifying the wiring and control scheme. This is particularly useful in large installations or in applications where centralized control is desired. In retail displays, this lighting system can be used to highlight specific products or areas, drawing attention and creating visual interest. In stage lighting, it allows for precise control of lighting effects, creating dramatic and engaging performances. In architectural lighting, it can be used to accentuate building features and create ambience. In accent lighting, it can be used to highlight artwork, sculptures, or other decorative elements. In home automation systems, it can be integrated with other smart home devices to create customized lighting scenes and schedules. When troubleshooting, start with the basics. Firstly, check the power supply to ensure that the system is receiving power. Secondly, inspect the rocker switch to make sure it is functioning correctly. Test the switch with a multimeter to verify that it is opening and closing the control circuit properly. Thirdly, examine the relay for signs of damage or wear. Check the relay contacts to ensure they are clean and making good contact. Fourthly, test the transformer to ensure it is stepping down the voltage correctly. Use a voltmeter to measure the input and output voltages of the transformer. If the transformer is not outputting the correct voltage, it may need to be replaced. If the light is not working, check the bulb or light emitting diode, LED, element to make sure it is not burned out. Replace the bulb or LED if necessary. If the light is flickering, it could be due to loose connections or voltage fluctuations. Check all wiring connections to ensure they are tight and secure. Use a wiring tester to check for voltage drops or other wiring issues. If the transformer is buzzing or humming, it could be a sign of a faulty transformer or loose wiring. Check the transformer for signs of damage or overheating. Tighten all wiring connections to the transformer. If the problem persists, the transformer may need to be replaced. When replacing components, always use the correct type and rating. Using the wrong components can damage the system or create a safety hazard. Always follow the manufacturer's instructions when installing or replacing components. Regularly inspect the system for signs of wear or damage. Replace any damaged components immediately. Keep the system clean and free of debris. Dust and dirt can accumulate and cause components to overheat or fail. If you are not comfortable working with electrical systems, it is best to call a qualified electrician. Working with electricity can be dangerous, and it is important to take the necessary precautions to protect yourself. Always turn off the power before working on any electrical circuit. Use insulated tools and wear appropriate safety gear. Never work on electrical systems in wet or damp conditions. These systems can offer significant benefits in terms of energy efficiency, control, safety, and flexibility. By understanding the components, operation, and troubleshooting techniques, you can ensure that these systems operate safely and reliably for many years to come. Also, remember that local electrical code should be followed, along with the National Electrical Code. The National Electrical Code Article 411 covers lighting systems operating at 30 volts or less. Table 310.15. The 16 provides ampacities for conductors. Article 450 covers transformers. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. A typical 120 volts to 24 volts transformer might be rated at 100 volt amps. That means at 24 volts, it can supply 4.16 amps. The overcurrent protection for the primary side of the transformer is covered in Section 450.3. Also, grounding requirements for lighting systems are in Article 250. Understanding voltage drop is important so that the proper wire size can be chosen, because voltage drop can cause lights to dim. Voltage drop is calculated using Ohm's law. To improve energy efficiency, consider using light-emitting diode, LED, fixtures. They use less power than incandescent or halogen bulbs. Also, consider using a lighting control system to automate the lighting. This can help to reduce energy consumption and improve the overall efficiency of the system. Remember, regular maintenance is important to ensure that the system operates safely and reliably.